We're going to do the full set known. So let's come down here, full cation set known. We've got them here. You notice we have a precipitate right off the bat. We'll get rid of that. This is now the antimony and tin. We've talked about how to separate those. You go very basic. The tin will go into solution, the antimony won't. And then you come back and confirm them by their sulfides, which have very characteristic colors. So let's set that aside. Now we need to check for sodium and potassium. We have to do this before we add sodium chloride to bring down the chlorides. So let's check for potassium. There's the potassium color. Sodium, there's the sodium color. So we've got those checked. Let's bring down the chlorides. So again, we've talked about those and about how to do that. In fact, let's just clear this out in anticipation of needing more test tube rack space. So now we have this full set of cations. We're going to take this all the way basic with NaOH. If we have ammonium cation, we'll have to use the magic nose. The blue color indicates that we do have ammonium. So let's spin this out and see what we have. So you notice we have all of these hydroxides. We'll move this over. We'll deal with these later. These are all the soluble ones. We've done this a little bit differently. Normally we've been taking out the barium and the strontium. Only in this case we want to keep them soluble so that we can get these other cations separated as well, the aluminum, the chromium. If we have ammonium in there, we will get this this copper ammonium complex. The other ones will come down just fine. So that's a little bit different if you don't have ammonium. So we've got these. Let's now acidify it. It brings everything into solution, and now we'll get rid of the barium and the strontium. And so we'll add the sulfate. There goes the barium. We'll increase the pH to 4, and there's the strontium. We'll take both of them out together just in the interest of time. So now we have these cations right here. And so we want to find out how to do this next. Let's take it to pH 10, and we've got then the aluminum and the chromium come down. The copper would remain as an ammonium complex, as would the zinc. And again, this is because we have ammonium in here. So let's bring this down. Here's our aluminum and chromium. Let's take this to basic conditions and oxidize it, and then drop, and that's got the characteristic chromate color. And so if we drop pH down to 10, we can get rid of the aluminum, and we can separate the aluminum and the chromium. So we've got those. Let's now take what's left over. So this is the copper, the vanadium, and the zinc. And so we're going to acidify this. We'll add the sulfate. The copper forms a very strong sulfate, very low KSP. So here is now the vanadium and the zinc. We'll increase the pH to 4 to 7, and you notice the zinc will fall out, and so we can get the zinc. And so there's our zinc, and this is going to have the vanadium, but if we acidify it, you get this beautiful blue color, characteristic of the vanadium, and then if you make it basic, you get the cherry red. So we've got those. Now let's go back to this other side. We have all of these right here. We're going to take out the calcium. So we're going to drop the pH to 10. And so that's going to allow us to get a hold of the calcium. You may get a clear solution, but confirm that with adding the carbonate. So we've got now the calcium out of there. We have all these the rest of these. And so now we're going to drop the pH. That'll take care of we'll be able to get the mercury out. It's insoluble, so we've got it out. We've got it now under acidic conditions. And so all of these, let's see, what do we need to do? Let's take it now to pH 7. You notice that these three hydroxides are much less insoluble, the titanium, the iron the iron and the bismuth. Let's spin those out. And so now we have these right here. Let's drop the pH. Bismuth sulfide is very insoluble. We'll spin that one down, decant it. And so there's our bismuth. Now we have to separate the titanium and the iron. Remember, we have the sulfide in there. Let's take the pH up to 4. The titanium forms a hydroxide. And so we've got the titanium, and now the iron, yeah, there's the titanium. Okay, the iron right here, as we increase the pH to 7, we get the iron sulfide. Okay, that leaves us now the cadmium, the cobalt, magnesium, and manganese and nickel. We're going to separate these two out right here by adding ammonia. And you notice everything forms an ammonium complex except the magnesium and manganese. We'll spin those out. And so here's our magnesium and manganese. Manganese you can oxidize, and the magnesium will go back into solution. When you drop the pH, the manganese will come out. And the magnesium, you can then raise the pH and check to make sure that you have the magnesium. So that just leaves these guys who are all ammonium complexes. We're going to drop the well, first of all, we're going to raise the pH, oxidize the cobalt, and that gives a very insoluble hydroxide. We'll acidify it, and you notice the cobalt is there. We've got it then away from the others. So we just now have the cadmium and the nickel. We're now going to make a sulfide. You get the very characteristic cadmium sulfide that is very insoluble. The nickel is a little bit more soluble. And so as you raise the pH up to 7, you get the nickel sulfide. Again, we have that nice characteristic green color of the nickel.